Welcome back to this lecture series on deep learning. In this lecture, we'll discuss about the topics errors in machine learning and what is bias and what is variance. First, we'll see what is an error in machine learning. So, in machine learning, an error refers to the discrepancy between the predicted output by the model and the actual target values. Say, for example, my target value is 10, but I'm getting only 9. The error is 10 minus 9. The error is 1. When we build a model, we aim to minimize this prediction error so that it performs well on unseen data and understand that is unseen data. Understanding error is an important because it tells us how far off our model is from reality and whether it is reliable for real world use or not. So we have to learn what is error, and the error is very, very important in machine learning. So this error only says that how far the model is from the real world data. It will says us. And the types of errors are, there are two types, reducible error and irreducible error. First, the reducible error can be minimized by improving the model, such as adjusting the algorithm, adding features, or choosing better hyperparameters. These mainly include bias and variance, both of which stem from the model's learning behavior. In contrast, irreducible error. So, reducible error means it can be minimized by improving the model by using the terms bias and variance. So, in contrast, irreducible errors are due to factors outside the model control, such as noise in data, unknown variables, or measurement errors, and cannot be eliminated regardless of how good the model is. So we cannot able to reduce it. So first, understanding bias. Bias is a type of error that occurs when a model makes consistent mistakes because consistently, that is continuously making an error, consistent mistakes because it has overly simplistic assumptions about the data. A high bias model tends to miss important patterns in the data and fails to capture the complexity of real world relationship between input and output variables. Next, the high bias, how it will happen means it happens when the model is too constrained or simple to represent the underlying structure in the data. It usually leads to underfitting where both training and test errors are high. Underfitting may occur in this case. For example, linear regression can be too simple to capture nonlinear patterns, resulting in poor performance. Next, low bias indicates that the model has enough flexibility to closely match the training data. This generally allows it to learn more accurate patterns and make better predictions. Models like decision trees or k nearest neighbors are often low in bias because they adapt well to complexity in the dataset. And the main key point about the bias is a measure of how far the average model prediction is from the true output. It focuses on accuracy of model on training data, whether the model assumptions lead to consistently miss the mark. So the next, reducing high bias. How we are going to reduce the high bias errors? High bias, the problems are when the model has high bias, it oversimplifies the data and misses key relationships. This leads to consistently poor predictions on both training and test sets, indicating that the model is underfitting and not learning properly from the data. And ways to reduce the bias, or one way to reduce bias is to increase the complexity of the model. So we have to increase the complexity of the model. First thing, for the first thing we have to consider the complexity of the model should be increased. So this is the first case. For example, moving from a linear model to a polynomial model can help. So moving from the simple model, linear model to polynomial, it is a complexity. Adding more relevant features can also provide model with additional information to improve it learning. So another method is, so add the inputs. Next, The another method is to reduce the effects of regularization techniques. So we know that the regularization techniques, this we have seen in the previous lectures, L1 or L2 methods, which may be constraining the model too much. Next, the goal in bias reduction is the objective is to help the model become more expressive, allowing it to better capture the patterns in the data. This improves accuracy on both the training and test sets and results in lower total error. Next, understanding the variance. Variance measures how much a model prediction, first variance, so it predicts, measures how much a model's prediction change when it is trained on different subsets of the data. High variance models what it will do is learns even though the noise in the training data, leading to large changes in output with the slight changes in the input data. Even if you are changing the slight changes in the input data, there may be larger variations in the output data. So high variance means it occurs when the model is overly complex, the first case, overly complex and fit the training data too closely. This leads to overfitting, where the model performs well on training data but poorly on new unseen data. It captures noise instead of general patterns. Next, low variance. Low variance means the model is stable and it's predictable to not change drastically when trained on different data samples. Such models are usually more generalizable. Simple models like linear regression tend to have low variance. Next, the key points on variance. Variance is a measure of model's flexibility and sensitivity. A model with high variance may appear to perform well during training but lacks consistency when exposed to new data, which makes it unreliable for real world applications. Next, reducing the high variance. High variance, the problems are a model with high variance is too tuned to training data and fails to generalize. It performs with high accuracy during training but fails to maintain that accuracy on validation or test sets, indicating overfitting. Next, ways to reduce variance. Simplifying the model can help control variance. This might involve reducing number of parameters, switching less complex algorithms, and reducing the input features, space or dimensionality through the feature selection or PCA, principal component analysis, is also useful. Adding more training data gives model a better change to generalize. Increasing the regularization, that is L2 penalty. If you are increasing this is one type. This we have seen it in the previous lectures. Can also control how much the model relies on the training set. Next, the goal in variance reduction is the goal is to improve the model's ability to generalize the across data set. A model with lower variance will perform more consistently across different data samples and will be more dependable in real world scenarios. Next, bias variance combination. This four rows are very, very important. Low bias and low variance. It is the best case. This is the ideal scenario. This is the ideal model scenario where the model predicts accurately and consistently. The model generalizes well and performs strongly on both training and test data. However, achieving this balance is rare in practice. Next, the low bias and high variance. Here, the model fits the training data well. Training data, in this case, training may be well and low bias but overly sensitive to data variations, high variance, resulting in overfitting. It memorizes pattern instead of learning general rules. Next, high bias and low variance. This case leads to underfitting where the model is too simple to learn from data. Though it's consistent low variance, it makes the same wrong predictions repeatedly due to high bias. And high bias and high variance, High bias, the fourth case is high bias, and it is the worst case. So as far as this case is considered as a worst case, this is the most undesirable combination. The model is both too simple to learn, that means high bias, or too unstable across data sets, means high variance. It fails in every scenario, making poor and inconsistent predictions. However, to identify bias and variance issues, if the model hmm, so what it will model if the model shows high error on both training and test sets, it's likely suffering from high bias. If the training error is low but the test error is high, it likely due to high variance. Next, bias variance trade-off. What is trade-off? Trade-off means what? The bias variance trade-off is about finding the important part between underfitting and overfitting. So we need to find out which case the underfitting occurs and overfitting occurs. As model complexity increases, bias decreases because the model learns better. However, variance increases because it starts capturing noise. And the key insights are balancing these two errors is essential. A complex model may seem better during training but might generalize poorly due to high variance. A simple model might not capture key parameters, key features, leading to high bias. We must select the model that is just right. We have to select for the problem at hand. And the model selection, how it would be: simple model like linear regression, generally simple model linear generally have high bias but a low variance. Complex models like decision trees or neural networks. So complex means neural networks or decision trees. Here this is the linear regression model. LR means linear regression model. The complex models like decision trees or neural network often have low bias but high variance. Regularization and cross validation helps in adjusting this balance. And the goal and trade-off is the goal is to find model that achieves the lowest possible total error, not necessarily the lowest bias or variance individually, but balance of both to optimize performance on new data. So hope everyone understood about what is bias, what is variance, what is error. So the remaining things we'll discuss in the next lecture. Thank you.